Hello, welcome to this video of the Lead3 synthesizer. This is not a new machine by any stretch of the world. It's a synthesizer that was launched in 2001 and went out of production in 2007. But there has yet to be made a reasonably decent video demonstrating the individual modules in it to any great detail. So I thought I'd try to go through the general structure and the internal modules in the synthesizer. First of all, this is a Nord lead, and virtually all Nord leads have the same basic architecture. You have a dual oscillator section in the middle, you have a filter with its associated envelope, and you have an amplifier envelope. Then you have two LFOs and a modulation envelope. And that's the sort of basics. All Nord leads are based around that concept. With this machine, this particular version was launched after the Nord Lead 2, and as such it was an incredibly step up from the Nord Lead 2. First of all, as you can see, there are lots of small light emitting diodes here, some green, some red, and these actually are rings around the knobs. If I turn the filter frequency, you'll see how the lead ring follows suit. And the idea is that not only does this machine have knobs in order to make it easy to tweak, it also has instant visibility of the sound. If I change a sound, bring up another patch, all the knobs immediately show which position they're in. And of course the idea is to immediately be able to visualize what makes the sound, how the parameters are set, and also to make it easier to tweak because you can see where they are to start with when you start tweaking. This concept was given up after the Nord Lead 3. Probably that being a great idea, it was still too expensive to survive in the marketplace. Indeed, this whole machine I don't think sold very well. This machine is one of the last, I believe, manufactured, and its serial number is about 4,500, which gives you an idea of how many they made during that 6-year period while it was produced. What was new in this machine is not only the fact that they used these lead rings for parameter indication. There's also an LCD display, which was also first for a Nord, and also the last for a Nord lead. The subsequent Nord Lead 4 and the Nord Lead A1 do not have, neither did the predecessors, which gives us the ability to name patches. Great idea. Unfortunately, I think again this concept proved as a whole too expensive for the general marketplace. But these machines are coming down in price now with new machines being launched, so it's worth taking a closer look at it, as they can be had for a reasonable amount of money on the second-hand market. So let's dive in here. Thankfully, Clavia, who manufacture this machine, have given us a sound init function. So we can quite simply it sets up a very basic patch with a sawtooth wave. So let's start with that. We'll start by looking at the oscillator section. Keep the filter wide open, no special envelope. Just look at the oscillator section. So we have two oscillators here. There's oscillator 1 in this panel and oscillator 2 over here. Oscillator 1 does not have a lot of control. There's a waveform control, classic wave shapes including triangle. Noise is also considered a wave shape, and something called dual sine mode, which we'll get back to. There's no octave switch for oscillator 1. Instead, there's a general There's an octave switch for the whole patch, and that's what oscillator 1 runs off of. There's a shape control, which sadly for the sawtooth wave does not actually do anything. For the pulse wave, you get pulse width modulation. You can set the pulse width. You can see the display. I don't think it's visible in the video, but the display actually shows the pulse width in percentages, in tenths of a percent. So you get classic PWM that way. You've got a triangle wave. When you sweep the shape control, it actually does some sort of a folding algorithm. Which, if swept back and forth, gives some sort of a detuned effect. There's a triangle, sorry, a sine wave. The sine wave, when using the shape parameter, you actually introduce a feedback loop in the sense of a frequency modulation, an FM synthesizer, which gives a bit of a sharper sound without going all the way to a sawtooth. The noise, there's a surprise, because this actually then functions as a 12 decibel per octave filter, low pass filter for the noise. So if we dive in, let's set LFO1 to modulate the shape of oscillator 1, and sawtooth wave there. Just as an example. Then we have the dual sine mode. Here we have two sine waves. With the shape control at 0, you only hear one. Bringing it up, don't get much of a difference, but you actually get a second sine wave 1 octave up. And oscillator 2 has a similar mode, meaning you can actually create a 4 sine wave oscillator if you want. Then comes the fun bit. Then comes the FM button. There's a shift button here which accesses lots of functions that are not directly accessible using a single button. And by pressing the shift we get FM, frequency modulation. And if you've ever heard a Nord Lead 2 or a Nord Lead 1, that's typical Nord Lead FM. It's the do everything button, as it were. If you select any of the other wave shapes, you get something else with this. Beside this little red LED here, it says sync. So what Klaviyo have done here is that they've when this is illuminated and it's not a dual sine wave mode, you get a synchronization wave shape, which essentially is a second oscillator that's brought in to do the sync sound with just one oscillator. So you've still got the oscillator 2 to do other effects with. And of course sync works with all the wave shapes, including noise. This is an effect called syncable noise, which basically is a small section of a noise waveform, and by sweeping the shape knob, you select different parts of a noise of some sort of a normalized noise wave shape to give you these very bright and slightly featureless, gritty sounds. If we go over to oscillator 2, there's an oscillator mixer here where you can select between oscillator 1 and 2. Oscillator 2 is endowed with a few more knobs. We have a coarse control, which sets the frequency in semitones, and there's a fine control as well. We have the same basic wave shapes. We have a sawtooth, which again sadly has no shape control. Modern synthesizers have something called super saw, where you in effect simulate the effect of having two sawtooth oscillators beating against each other. But unfortunately, Nord Lead 3, for some reason they decided not to put that in. It wasn't as popular then as it is now, and in fact super saw in those days was more of a gimmick to simulate like 6 or 7 sawtooth oscillators, which tends to give a bit of a bland sound, even though it initially sounds very, very, very powerful. We have the same wave shapes as the oscillator 1. The noise is slightly different because we have a selection here of a low pass, band pass, or high pass noise filter. And the shape control doubles as a resonance control for the noise filter. So of course we can dial up. If we turn off FM on oscillator 1, we could dial up noise here too. So in effect we can get noise with 2 filters without even using the filter section. And the reason for all this is, of course, that Clavia, having gone to the expense of putting in these knobs with the lead rings, want to maximize the usage. So there's very few modes where a knob actually doesn't do anything. Again, we have FM. It's more advanced on oscillator 2 because in the FM mode here, you can set the pitch of one oscillator and the second one. So you can set the pitch of the bass oscillator, the carrier, and the modulator using the coarse and fine controls. Then we come to the oscillator modulation section. That's when we can combine the 2 oscillators in various ways. What I'm going to do here is focus on is go back to some sawtooth waves, because that makes it easier to hear what's going on. So here we have your classic dual sawtooth with a bit of detune here. Incidentally, as you can see, the 0 position, when there is a well-defined 0 position on a control, it's usually green. So when a knob has a green LED illuminated on the LED ring, it means there's the actual value set to 0. So when fine control is green, we have no pitch detune at all. Increase, and we get quite a bit. There are a number of what they call oscillator modulation modes. There are various types of filters and filter modulations frequency modulation modes. There are 2 where we're going to set up 2 sine waves here, and we're going to switch the modulation section to a mode called FM. This again brings in FM, except now it's between the 2 oscillators. So if we'd set up FM individually on each oscillator, we would actually get a 4-operator FM engine, as it were. There are 2 types of frequency modulation on this machine. There's something called ordinary FM, which again you recognize from a Nord lead or Nord lead 2 if you've heard one. And there's something called differential FM. And the difference has to do with the way the frequency modulation scales across the keyboard. Differential frequency modulation mimics the way a DX7 works. So you basically get the same tonal characteristic across the whole keyboard. Whereas with FM, it tends to vary. It gets much buzzier at the low end. It depends on what kind of sound you're trying to create. If you want to create a nice FM Rhodes piano, then of course you'd need the DFM mode. There's also a ring modulator mode, which when enabled you get the ring modulators patched in where oscillator 1 would normally be. So if I change the pitch here, you get classic ring modulation sounds. There are also a couple of other modulation modes. The most interesting of which, to my mind, is something called filter modulation, which we'll demonstrate by dialing up a sawtooth wave here again. Filter modulation puts oscillator 2 as a modulator for the filter. So we'll decrease the frequency of the filter and pull up this mode. And we get this effect which is hard to describe, hard to understand, because what we're doing is we're modulating the filter frequency with an audio oscillator, with oscillator 2. And it's not easy to understand what actually happens, but it can create some very interesting sounds. My favorite, if I can find it here, is if you we set a triangle wave so we don't get too many overtones in the modulation, and we set the frequency of oscillator 2 very far up, somewhere here, and oscillator 1 very far down. an even greater distance between the oscillators here. And of course, to just give an example, we can set the modulation envelope to sweep the oscillator mod parameter. Filter modulation from the oscillator is something that relatively few synthesizers have, and to my mind that sort of distinguishes the bread and butter synthesizers from the one where the designer actually wanted to create something more than just a basic synthesizer, something that was really something more creative. There's something called distortion, which is basically that you apply a certain amount of distortion to the oscillators. If we again go back to our basic patch here, 2 sawtooth oscillators, and we add some distortion. This also brings the level up a bit. Now if you listen carefully, you'll hear some weird side bands. As I sweep the frequency back and forth. And the thing is, with a digital synthesizer, it's very hard to introduce any form of distortion without creating sidebands that end up outside the Nyquist frequency and that consequently create aliasing when converting back to analog. Making an alias-free oscillator is fairly well known, and any linear operation such as filtering that you do or an amplifier won't change that, but any form of nonlinear modulation such as distortion creates lots of overtones that weren't there to start with. And they've done very well, but you can still hear some weird sounds in the background here. Sounds like noise and other frequencies going on. Finally, there's something called distortion modulation, which is a way that Klaviyo have devised to try and create maximum grunge from the oscillator section. You get ring modulation, and using a third oscillator whose frequency is controlled by the modulation controller. So if we go all the way, put in FM for the 2 oscillators, we can get a maximum amount of chaotic sounds from the oscillator section. We won't go into that any further right now. Instead, we'll go over to the filter. So let's see now. We're going to go back to, let's see, we need to turn this off because we don't want sync from the oscillators. We're going back to a simple sawtooth because we're going to look at the filters. And we have here a filter section which has 2 modes. There's a single filter mode and a multi-filter mode. The single filter mode has the classic low pass, high pass, and band pass filters in 24, 12, and 6 decibel per octave versions. Now 24 and 12 is fairly common. It's 24, 12 is here, and then 6 decibel per octave is even blander. That's an unusual setting. I haven't come across any other synthesizer that actually has that mode, but I can imagine it'd be very useful if you set up a wave shape using frequency modulation that you really want in the filter, and you just want to trim the edge off a bit without having too powerful a filter, then you'd use the 6 decibel per octave setting. You have a high pass filter with the same modes. (24, 12, and 6), and there's a band pass filter again with the same modes. The 6 decibel per octave mode is actually more of an equalizer. You get a peak in the signal, but there's actually a pass band that stretches from 0 to infinity. So it basically just highlights a certain range of frequencies rather than cutting out a range of frequencies. There's a band reject filter, just rejects a pass band. There's the so-called classic filter mode, which is trying in some respect to emulate a classic Moog filter, classic mini Moog filter. And the difference is that the cutoff slope is not always 24 decibel per octaves as in the LP, normal LP mode. And there's also a bit of a the peak, the resonance peak is not as pronounced. It's a slightly narrower peak, which gives us a not as a pronounced resonance, not too over the top resonance effect. So we're going to try and see if we can demonstrate this. We turn up the resonance a bit. That's the classic filter. We'll go to the LP. You can see how the resonance really takes over. And of course we can turn it down, but then we don't get that resonance sound that we want. So if we set this up to sweep it with an envelope generator instead. That's the classic filter. Again, here, and this is the standard low pass filter. We'll go to a 24 decibel mode, sorry, to see if we can hear the difference clearer. The standard filter and the classic is here. Now, how well it emulates a mini-moog, I'm not sure. The manual basically says it does it to a certain extent. It's not as it gives a different sound, and I think there probably is it's probably very justified to have this mode here. Then again, there's the distortion low-pass filter, which is a 12 dB octave filter, which brings in this knob here as a distortion factor. So if we turn the envelope off, turn the resonance down, just bring up the cutoff a bit. Turned up the resonance a bit to hear the effect more clearly, and quite a bit of distortion. Again, this adds quite a bit of grunge to the sound, and I think the idea is to emulate a chord filter, an MS-20 filter of some sort, because that's also 12 dB octave filter, and they're known for quite a bit of distortion in the design as it is. There are a couple of interesting quirks. We haven't gone into everything in the oscillator or filter section. I'm going to highlight a few things. There's the keyboard tracking function, which basically gives you a one-to-one keyboard track. And if you want to use something else than a one-to-one relationship between the keyboard note value and the oscillator, then you have to go to the morph section. So I think we're going to go there and then go back to the filter and listen to the multi-filters, but we'll take a little detour into the morph section, which is over here. When you have morph on this machine, you have basically four different morph sources: velocity, keyboard, pitch, aftertouch, and a wheel, the modulation wheel. And if I press one of these, all the knobs go blank because I haven't set up any morphing. If I press the keyboard and advance the filter control a bit, the display will tell me that I now have a 54% keyboard tracking. And as you can see, there are two LEDs illuminated here. This shows the base value and how far it goes when the signal is maximum morph level. So here I get I get a certain amount of keyboard tracking, as it were, but not 100% as I had before with the KBT button depressed. You can set basically any frequency, any mapping down to minus 127%, which makes the sound progressively brighter as you go down the keyboard. A lot of these things can be a bit over the top, but there's a certain amount. It's nice to have a machine that doesn't try to limit you by saying, okay, you can only have 3 different keyboard tracking levels. You can have here. You can have basically whatever you want, whatever you need. So we've touched a bit on the morph. we'll go back to morph in a bit, but we're going to look at the multi-mode filter settings. Multi-filter settings, there are 6 of those as well. These actually introduce 2 filters with a common resonance control. There's filter 1, filter 2. The first setting is a low-pass filter and a band-pass filter in parallel. So if we listen here, you hear the band-pass filter. Here's the low-pass filter coming through. And both filters respond to resonance. We have, again, 2 filters in series. In this mode, that's a low-pass filter and a high-pass filter. So if you set the low-pass filter to the minimum frequency, the high-pass filter to the maximum frequency, sorry, they're not in the series, they're in parallel. Then you don't get anything coming through. But here it's quite nice because you can actually bring in a bit of top end. Even if you've got your low-pass filter closed a bit, you can bring in a bit of top end with the high-pass filter, a bit of buzziness. And again, both filters respond to resonance. Third mode is a low-pass and band-pass filter in parallel. In series, and that means that if we set the low pass for some reason the filters are swapped. So frequency, this one over here is the low pass filter, this one is the high pass filter, which is the opposite from the previous mode. Here we get the low pass filter, and here's our high pass filter in series. So if we set the low pass filter all the way down, the high pass filter all the way up, we get no sound whatsoever. So there are all ways of setting this up so you get complete silence, again with resonance. There is a mode with 2 bandpass filters in series, sorry, in parallel. And there are 2 all-pass filter modes which introduce 3 introduce filter type with 3 peaks in it. There's a 3-peak filter, where frequency 1 is the frequency 2 is the spread between the peaks. And being an all-pass filter, it actually introduces a pitch shift if you shift the oscillator frequency fast, or the filter frequency fast enough. And here's a multiband notch filter. I believe these would be good for introducing some sort of phasing effects. I don't find them terribly effective, but it's nice to have those modes as well. If we go on to the filter section, there's not much left here. There's an ADSR envelope generator. There's an envelope amount, which can be completely switched on to velocity. So if I set up a really basic patch here, an advanced envelope generator. Now if I turn on velocity, I get full velocity sensitivity. Now again, just as with the KBT, with the keyboard tracking, we can set up a morph for that. So if I don't want full full velocity sensitivity on the envelope amount, I can press my morph button and set a reasonable amount. It's a bit too little, let's increase that. And we get just a slight amount of velocity sensitivity. Again, you can set up any crazy morph you want. You can set up a negative velocity amount, which means you get the maximum when you're playing softly, and no envelope when you play at the maximum level. The amplitude amplifier envelope is not too exciting. It's an ADSR envelope, and then there's an output level that you can set per patch. There are a few interesting quirks with the envelopes. There's normally these envelope generators have linear attack phases, with the decay and the release phases being exponential. If you set up a very long attack, this would be the base of some sort of a pad patch. But if you want the sound to sound more like it's being played backwards, you can switch on something here called the an exponential attack phase, which means that the attack, let's see if we can make it, you get an attack phase which starts slowly and then builds up quickly at the end. Otherwise it just creates a softness in the sound, but with this mode on, you get a sound that sort of sounds more backwards. I'm not sure how useful it is, but of course it just costs an extra lead. Accessing that parameter is a bit unusual. You press the shift button and then you turn, if you turn the attack knob to the right, you get the exponential mode, and if you just twist it to the left, you get the linear mode. Final few things in the filter. You can have an inverted envelope if you want to the filter. So if we go back to our patch here and set up an inverted envelope, we're left with that. And there's also a special mode where you can have oscillator 2 bypass the filter entirely. And if you remember here, first we set up a basic sawtooth patch. What I'm going to do now is flip over the oscillator mix to oscillator 2 and set up a very simple FM sound here. Now, very often if this were an FM synth, there would be no filter, and I can emulate that by bypassing the filter, letting oscillator 2 bypass the filter. Oscillator 1 is still affected by the filter, but oscillator 2 completely bypasses it. So if we set up a mixture here, we can get a mixture of sounds where one of them is actually not processed by the filter. If we go back to our basic synth patch again, we'll demonstrate the LFOs. This machine has got two LFOs, and unlike the Nord Lead 2 and the Nord Lead 4, they are actually two true LFOs. On the other Nord Lead, most other Nord Leads, one of the LFOs can double as an arpeggiator clock, which is a bit of wasteful of a low frequency oscillator, but it does enable you to, it does save on knobs. Here the arpeggiator clock is on a separate knob, and of course that always costs a few cents to have something extra like that. But here we have two completely independent LFOs, and as you can see they're winking nicely at us, which is a nice step up from the previous Nord Leads where you had no idea what the LFO frequency was. Now, basically there's a destination. I can set it up to be oscillator 1 pitch or oscillator 2 pitch, which won't be heard because I'm listening to oscillator 1. If we switch over to oscillator 2, we get the modulation there, and we can have both oscillators modulated. So there's the filter 1 and 2 or both. There's shape for oscillator 1 and 2 or both. There's the modulation, oscillator modulation parameter, that's this one. You can modulate the resonance, which is also a nice touch. Very few synthesizers have resonance modulation. So if we patch that in, let's see if we can set this up in a useful way. We'll set up a 12 decibel per octave standard filter. You can hear how the resonance comes and goes. And you can pan the stereo output. And there's no pan level, the pan control to position the sound within the stereo image. It's always in the middle, but you can modulate the pan to create various types of effects like this. Let's see now, I've done, here we go. we don't want the filter, we want the have the filter operate on both oscillators to make these demonstrations clearer. So, what kind of oscillator, what kind of waveforms are there? Well, there's the standard, if we go to a standard oscillator pitch modulation. There's the triangle wave, sawtooth, pulse, sample and hold. There's a sample and hold with slew rate limitation, so you don't get this step feeling, but you still get a number of distinct positions in the wave shape. And there's a stepped sawtooth waveform. I can't describe it in any way. If you imagine a sawtooth wave that's been slightly softened, and then a sine wave that's superimposed onto it with a higher frequency, creates some sort of a rhythmic effect there. This was LFO2. LFO1 has basically the same controls, except some of the destinations are different. Instead of pan, we have the amplifier level, and instead of resonance, we have oscillator mix. So we can actually sweep between the oscillators with oscillator 1 if we set with LFO1. Now they're set to the same wave shape, but if I set it up here, oscillator mix, I can pan between the oscillators. In this case, I've set up one oscillator with a sawtooth and the other one with a square wave. What is interesting here is that there are a number of interesting things with the LFOs. You can set them up in a one-shot mode, which means that you actually end up with an envelope generator instead, which is great because it means you've got not only the main amplifier and filter envelope, but you can also add additional envelope segments by using the LFOs. If we, for instance, set up LFO1 or LFO2 as a triangle sawtooth wave, and then we set it up in the envelope mode, or if we modulate the filter, and this is a good time to talk about the mono mode and the mono and poly modes on the LFOs, which is not a concept that's immediately intuitive if you haven't actually designed or built a polyphonic synthesizer before. With a polyphonic synthesizer, of course, all these parameters are basically duplicated once for each voice, but classically, when you build a synthesizer, you want to minimize the amount of parts, so of course you make the oscillators and filters and envelopes and everything per voice. But the LFOs would normally be one for all the voices. When you're making digital synthesizer, it just requires processing power, and an LFO doesn't require as much processing power as the other parts, so you can have a bit of luxury here. If we listen to a oscillator modulation here, here we've got a monophonic LFO modulation. So if I play a chord, the whole chord is being modulated in the same phase. If I turn mono off, I get one LFO per voice. So they're all going at the same speed, but they come in different phases. Especially if I enable something called keyboard sync. That means that the LFO starts at the same phase whenever I press a new key. I get a completely different sound from when I have the mono position, where there's only one LFO modulating all voices. Now, what you want there is it depends on the sound you want to create, but there's at least a possibility. Also, the LFOs can be synchronized to a master clock if you want to have effects that either if you want to synchronize the oscillators against each other or against an incoming MIDI clock or against the arpeggiator. You can also invert the amount of modulations if you want a negative modulation amount. That's only valid for certain parameters that normally only go positive. And then we have a modulation amplifier, a modulation envelope, with an attack and decay or release control. So it's quite a basic envelope. but it's very nice to have a completely separate envelope to the other features. This envelope can, again, you can use it to modulate the oscillators, which we'll do very briefly here. Turn up that a bit. Sorry, there. I'm just modulating oscillator 1. You can use it as an auto bend if we set it up to have an inverted output. We can use it as an auto bend, or we can use it as an auto bend for both oscillators. It can modulate the filters, the shape of the oscillators. It can also modulate the LFO1 level, which would be great for creating delayed vibrato. If we set up LFO1 to put up quite a hefty vibrato effect, but we turn the output level of of the LFO down to 0, and instead advance the modulation envelope, where we set the attack to inverted, attack to 0, and decay to a certain level. We get this delayed vibrato effect, which we also can reach by switching off the invert and using the attack to create the delay vibrato, and switching the envelope to the attack release mode, which is what happens when this LED comes on here, by pressing Shift and turning the decay release. And finally, you can modulate the oscillator mixture and the oscillator modulation parameters, sort of like LFO1 can. The modulation envelope can also double as a low-frequency oscillator by setting it in the repeat mode. So if we do that, we can create. We basically have an LFO with separately configurable rise and fall times. So what we're going to do here is modulate the oscillators. And we need to set the envelope generator in the attack decay mode rather than attack release, because an attack decay envelope generator does not really have a repeat. Sorry, that's very fast here. We'll see what we can do. So that what we get here compared to an ordinary LFO is we can configure. We get a triangle or sawtooth wave where we can adjust the rise and fall times individually. So basically, what we have here are actually 3 separate envelope generators or LFOs, depending on how we configure it. Even though LFOs, the two modulators labeled LFOs are of course designed as LFOs primarily, but we can use them to good effect for envelopes. For instance, if we want to set up a patch where we have let's see, we'll take our very basic patch here again, and we want to set up a filter envelope that's very spiky. At the same time, we want a classical attack decay envelope that's slower. Well, we can set up an LFO2 for that, for instance, if we're not using it for anything else. Set it to envelope mode, set the destination to filter, so we get both this sound here, the ordinary envelope, what would you call a classic filter envelope, plus the spike that we added in from the ADSR envelope generator. And that means that we can create a lot of effects which would only be possible if we had a multi-stage envelope. Of course, they could have put it in a multi-stage envelope, but that would have given us lots of extra knobs, and knobs are expensive, as we know. So that is basically the whole oscillator section, the whole sound generation section. There are a couple of things I've left out purposely because it gets quite complex the way it is. And in fact, the main drawback I feel of this synthesizer is that it's very hard to actually determine what the oscillators will sound like if you set them up in a certain way. If you enable FM on them, you set up the modulation amounts, and the frequencies, it's very hard to predict what you're actually going to get. And they've tried to rectify that in later incarnations. For instance, the latest Nord Lead A1, where there's the oscillator instead has an oscillator configuration control where you can select between a number of preset configurations that Clavia have determined are the best ones, the most useful ones. Here there's a lot of work involved in trying to set it up, but it can be very rewarding to do that. And finally, I'd like to show a bit more about the morph features here. If we turn this envelope off, we as I mentioned, we have aftertouch. We can, for instance, set the aftertouch to the filter. A little drawback of this machine is that the aftertouch is very sensitive. Once you get to the aftertouch level, it's very easy to exercise the whole range. We can have aftertouch going up. At the same time, we might want to lower the volume a bit. At the same time, we can set the wheel to have some sort of LFO modulation. Or simply use the wheel to do something with the resonance and then the frequency at the same time. So we'll set we'll have the wheel decrease the frequency but increase the resonance. Not too an interesting effect maybe, but it does demonstrate the feature. And also, as you can see, when as you can see here, when I'm operating the wheel, the knobs not only show the current value, but also the value after the morph, which is great, because you actually all the time you can see what's going on, even though it does look like a flashing Christmas tree here. Incidentally, the aftertouch can also be used for the control pedal input, and then of course we have keyboard morph, which I think is great. They don't have that on any of the other Nords, and there are instances where it's very, very useful. For instance, if I set up a very, very basic patch here, where I want the keyboard, we'll put a low sustain, where I want the sound to be shorter as you go up the keyboard. Now that's usually the case for a stringed instrument. The big strings, the long strings, big strings have more of a decay, but here I get the same all the way. So what I can do is I can set up a velocity morph where a keyboard morph where I decrease the decay as I advance up the keyboard. I've exaggerated the effect here to give a feeling for how it would work. Things like that I find are very useful, and since having a morph, this type of a morph arrangement, means that instead of having to set up a number of modulation routings as you would in a what I would call a conventional synthesizer today, you just quickly press some of the morph buttons. You can set up anything from any controller. Now there are drawbacks to it too, of course. The fact is that there isn't a modulation matrix. You can't modulate anything with anything else, although I must say that the preset modulation patches on the Nord Lead3 are quite comprehensive. There are lots of things you can do here. And I think at the moment I just want to demonstrate one other thing there, that not only do we have these LFOs here, we also have a vibrato section over here. I think they determined that one of the most common uses for an LFO would be vibrato, so they have a very simple vibrato section which can be brought in by the wheel or aftertouch. Set the amount. Which means you can do vibrato without having to tie up an oscillator, which is a great feature. But this is basically the sound parameters of the machine. I'm not going to, in this video, I won't go into this section over here, which controls things like the arpeggiator, the glide functionality, and things like that. That's for a later day. But I'll leave it at this.